All right, we're still working on skill number 3, but in this video, we are going to be applying what we learned about combining like terms and the distributive property to go ahead and simplify some expressions. So let's take a look at our basic steps for simplifying expressions, and then we'll go into some examples. So step 1 is always to distribute to eliminate parentheses if you have them. So if you don't have parentheses, you can skip that step for distribution, but that should always be what you're thinking about first. Step 2, we want to identify the like terms. So once we've distributed, can we figure out which terms are alike? And I'm going to show you how I kind of like to code the like terms so that it's easier to make sure we're not forgetting to put like terms together, and we're also not forgetting to take their signs with them. Step 3, this is where we talk about reordering the expression so that the like terms are next to each other and making sure that we keep the sign with the term. Once you get confident with this skill of simplifying, you may not always need a reorder, but I think it's a good strategy for making sure that you don't miss anything. And then finally, step 4 would be to add and subtract those like terms so that we have a simplified expression. So let's go ahead and take a look at the first one. And in this first example, you notice that there are no parentheses, so we can go ahead and skip step 1. That guy's done. Okay, the next step is going to be to identify those like terms. And this is where I was talking about I like to kind of code them. So I code with just shapes. You can code with colors, whatever makes the most sense to you. But I'm going to be coding with shapes. So I've got this 7y, and I know that it is a like term with the 12y. I'm going to make sure that I include the sign that is in front of it. So in this case, that 12y is positive, so I'm going to keep that addition sign with it. Okay. The other two terms do not have a y, so I'm going to code those differently. Maybe I'll use a circle, but I'm going to keep the signs with them. So this is a +6 and a -1, and there's a little bit of overlap here, but that's okay. So that's identifying those like terms. Okay, the next step is to go ahead and reorder the terms so that they are next to each other. So I'm going to take this 7y, since it's in front, I'm going to keep it there. And I'm going to move its like term right next to it. So I'm going to take the sign with it, plus 12y. And then I'm going to continue with my next set. So those are my circles. That's that +6 -1. So I've reordered, I've kept the sign with it, and now I'm just going to add or subtract to simplify. So remember, you can only combine what was a like term. So I'm going to take the 7y and the 12y. I'm going to add them because that's what it's telling us to do right here. And that gets me 19y. And then if I look at the second set of terms, that's the +6 -1. Well, +6 -1 is a +5. And since 19y and 5 are not like terms, I cannot simplify anymore. So this would be our final answer, 19y + 5. Okay, let's try the next one. So again, I'm going to look at my steps here, go back and just kind of go through step 1. We notice that this time I do have parentheses, which means there's something to distribute. Okay, this one I have a negative in front. I could also think of that as having a -1 in front. We don't see it, but it is there. So I'm going to distribute a -1 into the parentheses first. So that looks like -1 times 8 plus -1 times 4k. Whoops. Okay. And then because the 6 is not in the parentheses, that's not going to get the -1 distributed to it. So I'm just going to say +6. I'm kind of just bringing it along. Now let's simplify that. So -1 times 8 is -8, plus a -1 times 4k is a -4k. And then again, I have this +6. Okay, here is where we want to then move on to identifying like terms because we've done the distribution. So if I'm looking at like terms, I've got this 4k, -4k, and there's no other term that has a k. So this is going to kind of be by itself. It's a negative. And then I have the -8. That doesn't have a k, so I'm going to use a different shape, my circle. and the positive 6. Okay, it doesn't matter what comes first. I like to put my variables first, so I'm going to put negative 4k in front. This is step 3 where we're reordering the terms. And then there's no other k terms, so I'm going to move on to my circles, which are my constants. I have a negative 8. I'm bringing that negative with it. And then a positive 6. And now there's nothing to combine with the negative 4k, so that stays the same. And now we have to think back to our integer operation rules. So I have a negative 8 plus 6. When I'm adding with different signs, so negative and positive, I really subtract, and I keep the sign that has the larger absolute value. So a negative 8 plus 6 is going to get me a negative 2. And then that is our final answer, because a negative 4k and a negative 2 are not like terms. All right, one last one. We threw in some fractions here because sometimes that gives us a little bit of hesitation when we're solving these problems, but we can handle this. So again, going back to our steps here, step 1, which I still have crossed out, but step 1 is to distribute to eliminate parentheses, and we definitely have 2 sets of parentheses here. So I'm going to distribute twice. I'm going to distribute this 5 here to the z and to the minus 4. And then this guy, we need to be careful. I am distributing this whole thing. So when I say this whole thing, I'm talking about this negative 1/2. This whole thing right here needs to go into the parentheses. So a negative 1/2 times 6z and a negative 1/2 times this 2. So let's get to it. We've got 5 times z minus 5 times 4. And then my second distribution, I've got minus 1/2 times 6z minus, it's getting close to the edge, 1/2 times negative 2. All right, now we have a lot of simplifying to do. So let's go ahead and get to it. We've got 5 times z, which is 5z. A negative 5 times 4 is negative 20. A negative 1/2 times 6z, well, half of 6 is 3, so negative half of 6 is negative 3z. And a negative 1/2 times negative 2, half of 2 is 1, so this becomes a positive 1. All right, so really all we've done is distribute and kind of simplify. Now we're ready to move on to identifying those like terms. So I'm going to get my shapes and box in my 5z with my negative 3z, and my negative 20 with my positive 1. Those are my like terms. Now we can reorder for that third step. So I've got 5z minus 3z, and I've got negative 20 plus 1. And for our final step, we're going to add and subtract those like terms. So 5z minus 3z, that's 2z. And a negative 20 plus 1, you're adding with unlike signs. So we really subtract and then keep the sign of the larger absolute value. So if I subtract, I get 19. And the number that had the larger absolute value was the negative 20. So this becomes a minus. So our simplified expression after all that work is 2z minus 19. Okay, so I know there were a lot of steps there, but we tried to give a couple of different examples to help kind of guide you through what you might be asked to do when simplifying expressions. So starting with just looking at an example where you don't have to distribute. Then we looked at what happens when you have to distribute this negative sign. And finally, what happens when you might have to distribute twice, including a fraction, which might seem a little less friendly. So if you get stuck as you go into your matching practice, look back at your examples, look back at your steps. But let's go ahead and jump into this matching and make sure we understand what we're doing. So simplify each expression below, then write the number of the matching answer from the answer bank in the rectangle. Not all answers will be used. So let's look at this first one. There is no distribution, so I'm going to jump in right away with identifying my like terms. I've got a 3x and a positive 4x, and then I've got this positive 6 and a positive 18. So I'm going to rewrite it now so that my like terms are together. And what's nice about this one is it doesn't look like it has any negatives or subtraction. So it's just adding like terms now. And I've got 3x plus 4x, which is 7x, and a 6 plus 18, which gets me 24. So it looks like my final answer for this expression will be 7x plus 24. I can see that right here on number 7. So I'm going to go ahead and write 7 in my answer box and then cross it off here just so I'm not overlooking it. So you're going to match everything up. Again, if you get stuck, make sure you're asking questions, and good luck.